All right, guys, so we're going over the school interface 1 challenge. I have my files here. I have a school, class, and a runner file already created. I'm actually going to start by creating a new folder in my VS Code, and I'm going to name that classes. So the reason I'm doing this is, again, for file organization, or I guess folder organization, I kind of want to just have all my classes I create in a separate folder, just to kind of keep it away from my main file. So I'm actually going to move my school.py file into my classes folder, and now it's sitting over there. So I've copied this over from the README. So again, I have a name attribute, a staff list, and student list. If I look at my runner file, that's using my school object, creating an instance of school object with Ridgemont High, and it's attempting to print out the school name. So if I try to run this, actually, let's see what happens. So I'm going to bring up my terminal. I'm going to further. All right, so let's give this a run and see what happens. I do Python runner. All right, so I actually got an error, so that's not good. What's the issue here? Let's kind of read the error message. We got module not found, no module named school. So that's kind of interesting because I actually have a school module here. But the issue is I actually moved it into a folder, so I actually got to update my runner py, runner py file. So to handle that, I'm just going to add classes here because that's the name of the folder that I created. So it's like a module with a submodule in it. So I got classes.school. So now Python knows to look in the classes folder, and I could find the school module with the school class in there. All right, so I think that one change, just adding classes dot in my import statement, should handle it. So if I clear my screen, not type clear my terminal, and run that again. All right, so I got Ridgemont High printed out as I kind of wanted. So testing this seems to work, and we could proceed. All right, so I guess I'll use README here so I don't have to keep switching windows. Let's see. All right, now we probably want to create a student file and a staff file. So I'm just going to actually go into it, and we'll iterate from there. So let's get a new file in my classes. We'll call it student.py and staff. Sorry, let me mute my notifications also. Okay, so I'm just going to copy the code since, again, it's provided for me. I don't see the reason I need to type this thing. Again, whenever you're copying and pasting code, you should always make sure you understand what the code is doing. It's very easy to just copy and paste, but you should get in the habit of actually reading the code. So in this case, I can understand what this code is doing. It's initializing my staff object here with relevant details. There's nothing too fancy going on here. I'm going to copy that, put it in my staff file, and do the same with my students. All right, so not too difficult there so far. We got our models created. All right, so let's actually look at our staff and student files and see what we know. So, all right, I've split my window. So on the left, I have my student class that we just created or copied over, and then on the right, I have my staff class. So kind of looking at the data here, one thing that might jump out at you is that we actually have a lot of repeated information. So like we have a name attribute, age, password, role. I guess the only main difference is school ID versus employee ID, right? So again, this isn't terrible because there's not too many data members. We could definitely manage this, and it's not going to be a huge issue. But in working with classes, this is a good example of where, since we have a lot of repeated information, it might make sense to create a base class and then kind of inherit from that. So again, we're going to be talking about inheritance a little bit more in today's lecture, but this is a concept that hopefully you guys are sort of familiar with, even if not fully familiar with it. So I think our next step here, if we look at our README, is, we have repeated code. Maybe we should create a person-based class. All right, so there's a document that talks about inheritance. Again, our lecture today is about inheritance also, so maybe we're kind of jumping ahead slightly, but let's actually go forward and implement base class here. So I'm going to get rid of my split windows, too many windows for me, and I'm going to create a new file, and let's call it person.py. Very generic. And I'm going to create a class here, so class person. And this is going to be base class, so it doesn't inherit from anything, so I don't have to put anything in parentheses here. And let's actually copy over some of this redundant stuff. So I'm going to copy that portion, put that there. All right, so name, age, role, school ID is not the thing I want in this method. And then we also have this from staff. All right, so I'm going to delete this from staff and keep that there. All right, so what I've done is basically I extracted the shared information between my student class and my staff class, being name, age, password, and role. I'm just copying that and cropping that out of my classes. And then I'm actually putting it into this person class, which this person class is going to act as my base class. Again, just go over terminology. A base class is like a generic class, and then classes that are spawned off that, or I guess inherit from that, are called derived classes. So in this case, my student class is going to be derived from my person class. So I'm going to actually add that person class in here. Again, parentheses and the class name. This will say my student class is inheriting from my person class. Likewise, I want to do that with my staff class. But we have a small issue here. So again, similar to what was going on before, we actually need to tell Python where this person class is coming from, right? It doesn't magically know that we have this person file with a person class in it. Right? So again, we got to do an import statement. All right, so we're going to have to do an import. So if I go to my student file, I'm going to write from. And now some students had issues with this. Again, it's not intuitive. If I kind of look at this, I say, all right, I have my person file here in my classes folder. And then I also have my student file in that same folder. So I could likely just do student and then import student. So you would think that this should work, but if we actually try to run it, we'll see what happens. So let's see, how do I do this? All right, let me create a student object here, just for trial's sake. And I remember all my.
Looks like you're trying to import student into itself instead of person.
Thank you. That's not what I want to do. Good eyes there. All right, so I'm going to try to do that and see what happens. Get my runner file. All right, let me just fill out something here. We'll call him Bob. Bob's age, how old? Bob. Let's say he's 17. His role is student. The school ID will be 88, and his password will be password. Terrible password, but that's what Bob chose. So
you forgot.
Right. So we have a student object, but I need to import that just like my school object. And let's see if this actually runs. Student. All right, so let's clear my terminal and run my runner. And look, I got another module not found error. So again, reading error messages, a very important skill. If I kind of parse this, I can see that's actually complaining about my student.py file on line 2. So let's go to my student.py file, line 2. So this import statement, there's something not quite right about it. So again, as I said, I would assume I could just use person because person is in my folder, the same folder as my student file. But that's actually not quite how it works. So you're gonna have to specify, I guess, by using a dot. This will say this is the current directory. Another way I usually do it, again, this is more verbose and not really mandatory, but you can write in classes.person. So I kind of like doing that so I know that I'm going into my classes folder and then find the person object. So this, I do this because hypothetically, if I move my student file to maybe another folder or another location, this will still be able to find it correctly versus if I just have the dot person, this is reliant on the fact that they're both in the same directory. All right, so it's your option. I just like to be more verbose, so I'm actually going to put class.person and then import the person objects as I wanted. So I think that should fix up my module not found error. So if I clear my screen and then run my runner. Okay, so actually I wasn't doing anything with my student, but my student got created, didn't get any errors with it. Just make sure that I'm not lying about that. Print out student name and run that again. What? Oh, right, I screwed up. Sorry, kind of jumping steps there. Let's print out the age or student ID. All right, school ID is 88, so hopefully that should print out 88. All right, so we got 88. So the student object is being created here, and we print out the school ID. But I kind of, mess with the data in my school object, so that's something I want to refine. So as I kind of talked about, I created this person base class. This base class is holding my name, age, password, and role for my student object. However, if you kind of notice, that name that I pass into my student is not actually, like, we're not actually doing anything with it, right? We're capturing it. We have a base class of person, but we're not actually telling the person class that, hey, we have a name and age and a role that we could use in the person class, right? So we're only actually storing the school ID in this case, because that's what we pass in here, and that's specific to the student. But the person class needs to know about the information that, that we want to pass to it. So in this case, one way to do it is I could call the person class. So I'll use the person actually class name, capital P. I could call its init method and then pass the relevant information that I want to pass. In this case, name, age, role, and password. I believe is ordering. Yep, so name, age, role, password. So now that I've actually called the base method of init, I'll actually be storing my name, age, role, and password because it'll actually trigger this init function in person and store the relevant information. So as you may have seen before, when I was trying to do student.name, it complained, hey, the student doesn't have a name attribute assigned. The reason was because I wasn't passing the name, age, role, and password down to my base object person. All right. So if I do this now, my name should be set properly. So if I clear my screen, run that again. Oh, I got another error. Precisional arguments. Of course, I have an issue. So 4. I got to pass self in here. So this is one way to do it. You could use a class name, pass in an init, but then you got to pass in a self parameter. It's not auto magically passed in. So that was the issue. Yep. So I run this, I get Bob out here. So again, that's one way you could do it. You could use a class name and then call the method you want to call and then pass all the parameters, including self. In this case, self is not magically passed in. However, there's a slightly better way to do this. And again, it's not something we've covered, so maybe something you guys discovered or aren't familiar with. But actually, there's a method called super that is very useful in classes. And this will actually automatically identify the proper base class and basically substitute that class name in and call the init method. In this case, you don't have to pass in self. So if I make those changes, basically I added super instead of adding the person class. And again, in the lecture today, we'll talk about why you want to use super and kind of what it offers you. So again, don't worry if you don't know too much about super or even haven't used it before. But in this case, I just use super. I no longer had to pass in self, and it should achieve the same results. All right, so I still got Bob printed out. Again, I'm only passing in the values without the self as the first parameter. That's, again, magically going to be passed like normal. All right, so I've kind of hooked up my student class with my base class person. My person class is now storing some instance attributes. So the main reason we were doing this is because our staff also has similar attributes that we want to store in a shared base class. So to do that, I'm just going to kind of copy over what I just did, copy over my import statement, and copy over my super call.
Hey, Ankur, quick question.
Yep.
So me and my partner used super yesterday, and my partner had mentioned that one of the reasons why we use super was in case of like a class name change, that it doesn't define anything specific.
Yep. Absolutely. Yeah, great point. And that is one of the benefits of super. So what Jose was saying, he and his coding partner, they identified that super is kind of generic, as in if I hypothetically change the name of my person class. So I have two options here, right? let's say I had this version, and then again, I don't actually want to call my base class twice, but I just want to do this for highlighting purposes. So my two options were using super or using the base class name directly, and then having the self. So in this case, hypothetically, let's say I rename my person class to be like, people, or just like something else, like donuts, right? If I rename my base class, I'm going to have to update this also. So it may not seem like a huge deal right now because we only have one instance of it. Again, I'll have to, no matter what, I'm going to have to update my base class in this case. And update all this stuff. All right, so a couple updating, but in this case, I had to update my line here versus my super line may stay the same. And that is correct. So hypothetically, I might have had like 20 different references to person in my class if this class was like extended, had a lot of functionality. So it's going to be just a lot of find and replace. Again, we could probably just do that easily with VS Code, but it's easy. It's definitely possible you miss one case, and then that could lead to trouble down the line. Either won't compile, which isn't too bad, but maybe you have a separate person case, person class, and it's actually still trying to use that class as opposed to using your donuts class, which you want to do. So yeah, that's one benefit of super in that it kind of makes your coding easier. It makes it more, I guess, robust and seamless in terms of you change your code. It'll kind of seamlessly update for you without you having to make code changes. So good point, Jose. Yeah, that is a benefit of super, and that is why we encourage you to use it. Again, the lecture today we'll talk a little bit more about super and other benefits that it may offer. All right, any other questions with what we've done so far? Again, we talked about inheriting, which again is the topic for today. We talked about the super method, and let me fix all my donuts.
Is there a reason you use the super.init instead of just passing the parameters to super?
Like passing these parameters?
Yeah.
I'm not sure if that actually worked. So, never hurt to try. So something like this.
Yeah.
That might work actually. It's I'm not sure. I don't think. Let's see. Let's actually put them as students since I'm using students. All right. Go to my student. Sorry, some typing issues here. Copy that. Pass that there. Something like this.
I'm going to add an N to name.
Sorry, add what in it?
You missed an N on name.
Name. Thank you, thank you, thank you. All right.
Yeah.
So if I have something like this, let's see what happens. All right. So imports. I screwed up my donuts. Add when you have donuts on your mind, right?
It's like that pad thai commercial.
Yeah, that's good.
When all you can pad thai is think about.
All right, so yeah, so this actually won't work. So super isn't actually like a synonym for my base class. So in this case, super does take in some arguments, but those arguments are not what you would expect from the init method.
Gotcha.
So it's worth trying. Again, I do this all the time. If I'm curious, you can just run your code. It's not like nothing bad's gonna happen, right? You're not gonna break your computer if you like try to use something incorrectly, but it's worth a try. So in this case, yeah, we can't use super in the sense as a replacement, direct replacement for our base method. We still have to actually call in that method ourselves. So we're not able to do that. But again, great suggestion. I was also semi-curious with that. But yeah, in this case, you call super, which will kind of invoke the class, and then you want to call the init method on that.
Yeah, because when I was working on Sudoku, I did a little bit of inheritance, and so I didn't use super because I didn't know about it yet. And when I was able to just use the name of my class and pass the arguments in without directly referencing the init.
Gotcha.
So.
Gotcha. All right, cool. So that I think completes our release 0. So we created our classes, we created our school class, created a student class, a staff class, and then we did the extra of, we had redundant code. We wanted to kind of reduce that. So we created a base class. So hopefully you guys kind of read up on inheritance. Again, we're going over that today. So don't worry if you're kind of lost with inheritance at this point. So, all right. So I think I did a good chunk of work. So I've talked about this before, I think. It's always good to kind of have incremental commits, especially with larger projects. And as the projects get larger, you definitely want to commit more. The reason being, I have stuff that's working right now. Like I have a very simple runner file that creates a student object, a school object. I could create a staff object also if I wanted to, but I'm going to kind of pass on that. But yeah, so, it's kind of working. it has functionality. So I actually want to just kind of save that functionality into my version history. And the reason being is like, let's say I add like new features later and I somehow break my student class or break something in my application. I always have that save point in my Git repository that I can kind of roll back to or kind of reference and be like, okay, what did I change? Or actually, if I want to just roll back completely, I could just say, you know, discard my current changes, roll back to when I was working. And it just makes that much easier. Again, this is not like a huge project, but as your projects get like, you know, like thousands of lines of code, it makes sense. Like if you break something accidentally, you want to have that save point so you can revert back to your working conditions. So I'm just going to do a quick git add, git commit, and I'm going to say created my classes. All right, simple message. All right, so that committed to my local repository. I'm not going to actually push it up. I could if I want to, but my local repository has the data, so I could just do a git add, git commit, and kind of proceed from there. So that was release 0. Now let's move on to release 1. All right, so this is where we talk about quarks. So actually, again, it's kind of hard to read my BS. I'm going to go back to the web page. Quarks, again, this is something we might have mentioned before, but not talked about fully in detail. So let's get more familiar with quarks. The idea of quarks stands for keyword arguments, is that you might have a list of many parameters you need to pass into a function, and keeping the order of those parameters can get tricky. Again, in this case, we have 5 parameters. That's a fair number of parameters, but a function can take in like 20 parameters if that's how we designed it. So we kind of want to be agnostic about the ordering in that case, and we have a way to do that with quarks. So to do that, we can create a dictionary, and the dictionary will actually contain the names of the parameters that we need to pass in. So in this case, school ID, age, role, password, and name. And then we can simply use our double asterisks and kind of strip out those data members into named value lists, I guess. So to kind of see that in action, let's actually look at it. So when we do the asterisks or double asterisks with student info, it actually breaks it up into something that looks like this, where you have key and value pairs, and the key is the attribute or the parameter that you want to actually assign to when you're calling a function, and then the value is obviously the value that you want to pass to that parameter. All right, so actually, if you want to refactor our existing code, let's kind of go about doing that. Close my README, my student file. All right, so again, we have a bunch of parameters here. I actually just rather make that. Let's use the quarks here. So if I go to my runner file. All right, so I'm going to just test out quarks here. So I'm going to create a dictionary, let's say student info. And I'm just going to move all this into my dictionary, like so. And I'm going to have to give them, so these are my values. I'm going to have to give them keys. So that should be name. This was age. This was role. This was school ID, I believe. And password was password. Terrible password, but yeah, that's what Bob wants. His choice. All right, so we have a dictionary created here with information. And now I could simply just pass in that dictionary with double asterisks. So double asterisks and my student dictionary. And this should work as before. So I'm going to clear my screen and then run, just type in Python, runner.py. All right, still works as before. Again, we changed our code, but we got the same functionality. So we hopefully, likely didn't break anything. So that's a good sign. Let's go back to our README and see what else they want us to do. All right, so we kind of did this ahead of time, but again, just data organization. You want to have folders for your specific files. In this case, we have data files, Csc files in a data folder. We already created this classes folder and kind of moved our classes in there. So I kind of jumped ahead, I guess, from this README, but always good to organize your files, especially when you get, like hundreds of files. Folders will kind of make your life a little more sane when you're working with that many files. All right, so we have quarks going. hopefully there's not too many questions there, but again, I will pause in case there's any questions about parts. But again, the idea is basically to have name value pairs so that you could have any order you want. So just to prove that, if I change my age order and kind of put it last in my dictionary, that's not going to matter. Since I have the name or the key, the parameter name mapped to a value, the ordering is not going to matter here. So I can just run my code again, and yep, still found everything that's looking for. I guess I can move my name and put it in fourth, and that should still work. All right, so those are quarks. You guys might see those. Again, they can make coding a little simpler for you guys. So use them if you're comfortable with them. There's nothing that forces you guys to use them. So just another concept or Python specific concept that you guys can take advantage of. All right, that looks good to me. Let's actually go to our next release, loading data. So let's clear my screen there. All right, let's read about loading data. All right, so here we actually want to use our data files that that were supplied to us. So in this case, we had, I think an earlier day this week we went over reading from Csc files, but we want to go through this. All right, so again, we're just going to go through the motions of finding a CSV file, opening it, and reading data from it. Again, hopefully you guys have done this before with either past challenges or past lectures I've gone over this. So I'm going to actually get to that and see how I can make that work. So I'm actually going to go to my school file. And I'm going to create a method here. I'm going to call it all right, so sorry about that. Let's go to my student file and create a method here. And I'm going to call this load all students. And so the job of this function, as you might guess, is to actually load all the students from the data files I have. So if I want this to be an instance method, I would have the self keyword here. We're actually going to do something a little different here. We're going to create a class method. We're going to talk about what class methods are in case this is a new concept. So class methods are basically shared between all instances. So this is very similar to class attributes, where you might create, for example, if I had donuts here, this attribute would be, this donuts attribute would exist for every student instance that I create, and it's shared between them. There's not a unique donuts attribute for each student that I create. That's just I guess sort of a global attribute for every student that exists. Likewise, when you have create a class method, that method is shared by all instances that you would create. Versus instance methods are unique to each instance, as you can call each individually. Versus a class method, you could just call on the class without having an instance if you don't have one. So in this case, you use a decorator. In this case, the decorator we're using is called class method. Again, this is a reserved keyword or decorator in Python. So if I want to make this method a class method, I got to add a decorator just above it. All right, so self is usually used when you're passing in an instance reference, but in this case, we're not actually going to have an instance, so we're actually passing in a class. So we use CLS, short form for class methods. All right, but it's the same idea. It's going to be auto-magically passed in, just like self is passed in for instance methods. All right, so let's actually give some functionality here. So I'm actually, let's see. I want to load some data, so let's load some data. So I'm going to import CSV. I want to use that.
After this, can you tell me the difference between a class method and a static method?
Sure. I mean, I think static methods and class methods are very similar. I might actually have to read up on the differences there.
If it's a class method, do you not want it where, like, say your donuts example was right below class student?
Yeah, I guess it comes down to how you want to organize it. It's not technically going to matter where you put it, but it is a good point. Like if I want to keep all my shared class data, it might make sense. I like that suggestion. So I moved it up top. But again, the location is strictly arbitrary, so I can move my donuts like at the bottom. It's still going to work the same. It's just, yeah, for organization, you probably want to have some methodology. So I like Taylor's suggestion. Let's keep all of our class-specific stuff above, and then our instance stuff a little lower. And let's actually, so we want to read our data file. So let's just take a look at our data file, just to get familiar with what we're working with. So this is a comma-separated value file. That's what CSV stands for. In here, we have the first line is our header, and these are the values that are stored. And then we have our data. So we have a student named Lisa, age 25, who's a student. That's the role. And then we have a student ID, and password is XX. And that seems to be the password for all of them, which is fine. But yeah, so this is what our data file looks like. Basically, we want to read in this data and actually want to capitalize some of this, just for my sanity. But yeah, so we have this data. We want to read it in and create student objects from the data that we have. So that's our goal here. So we're going to read in the data. So let's go back to doing that. Path equals. So I have some code up here, so I'm just going to copy it. Actually, let's not do that. All right, we'll do OS path join. Path. Sorry, so I don't have this stuff memorized. If you guys think I do, that's I guess great, but I actually don't. I'm actually using a reference right now because I never remember all these path members and methods. All right, so got to use that and then have a file name. So let's give a file name. All right, so I actually want to find my students.csv file. So in this case, it's in my data folder. So I'm going to have to reference that. So I actually need to go up one level because I'm in my classes folder. I'm going to go up one level. So I'm at the main level and then go down to the data folder and then find my students.csv file. So again, file navigation can be kind of tricky. This is actually not the greatest because if I move my file, like move it to a more nested folder or move it to a different level, this actually could break. So, this isn't necessarily the best way of doing it, but for this case, I'm just gonna kind of hard code that because I don't anticipate moving my student file. All right, so I have my file name. I'm gonna pass that in here. Again, a lot of this is covered in CSV files. So if you're not familiar with what I'm doing right now, there are references you guys can gather. So I'm gonna have to import OS also. Complaining about that. All right, so I have my path and then my full path, I guess. So os.path .join my path. So sorry, here I need the generic. All right, so I think this is how it's supposed to be set up. I definitely will test it. But all right, so basically what I'm trying to do here is just find my file path and then create a full file path for it so that I can actually open that file up. It's a little tedious, not the greatest, but all right. So now that I have my file path hopefully correct, again, we'll have to test it. I'm going to do open and do my full path. And
Ankur, can I ask a question?
absolutely.
So I did it both ways. I had all this like my path, whatever stuff, but then I tried it with just the file like that you have, like the data students.csv.
Mhm.
I put that in where you have open, and it didn't make any difference.
Interesting. I like that idea. Seems much
I was
simpler.
just wondering, like, what's the
I actually don't know. So I wish I had a great answer for you. I am also mystified if this works just as well. I guess I would need to read up on why we actually recommend this OS path. Let's give that a try. I'll just use my file name. All right, let's see if that works. If that does, that's great. All right. I'm going to use something called dictionary reader. Again, this is something from our CSV lecture, but it's just something that's a handy tool to read out data from. Use some underscores. All right, so basically I just want to read out my data, and it's going to be read in via a dictionary. And then I'm going to do something like for line and file data, do some stuff with it. So I'm just going to print it out to make sure I'm actually getting what I want, and then I'll do more with it. So in this case, I'll print that one. All right, so again, main goal here was to find a file path, open it up, and then read data from it via the dict reader, which is a CSV class that kind of does some magic for us. All right, so let's actually test this out. So we have a class method, so let's actually look at how we actually call that class method. So if I go back to my runner file, I can get rid of my fake student here. Bob can go away. All right, so as I said, since this is a class method that we just created, we could just call student, which is the class. This is not an instance, and call load all students. And that should, ideally, if we did things correctly, print out all the lines from my student CSV file. So I want to see Lisa, Jesse, Slater, Kim, Dave, and Doug. All right, so let's give that a run. I don't have a student. Fingers crossed I haven't made any silly errors, but I usually have one. So let's run that, and of course there's an error. All right, so I got no file or directory, data students.csv. So Brendan, that might work. Again, I would have to kind of look into that more, but I'm actually going to stick with my test method of using the OS path. Again, I'm not quite sure what all this, why all this may be necessary, but if you got it to work without it, that's great. All right, so hopefully this works. If not, I'm going to have to do some further debugging. All right, cool. So again, I'm getting my full file path, opening that up, and then loading the data in via the dictionary reader. And now, as you can see, my output is a dictionary for each student. I have Lisa, Jesse, Slater with all the relevant information. All right, so I think I'm on the right track here. So I'm going to proceed. Instead of printing out my file, I'm actually going to create some student objects now. So, question, go for it.
Sure. I think in the lecture yesterday, they mentioned how the mode, like on line 15, we don't need to put mode R since reading is default, but it's good habit or like good standards to still include R or no?
Here?
Yeah, should we? So should we, even though that's the default or no?
I will defer to online docs. So again, I wouldn't be the authority on best practices. So if they recommend that, I would definitely say that's good. I could definitely see the argument, and this makes it super clear to the reader that, hey, we're only reading from this file. We don't want write permission. So yeah, I think that's totally reasonable to be more specific. Yeah, so yeah, thanks for kind of pointing that out. So this R just means this file is being opened as a read-only file. If you wanted to write, I believe that's W. I think there's a few others, like append might be A, but again, don't quote me on that. In this case, we just want to read from it. So in this case, we'll put that R in there. But yeah, always, for me, usually my practice is be more verbose if you can, even if you don't need to. So yeah, I guess I should get into the habit of adding that value in there. All right, so we created this class method. It reads this data. Now we actually want to do something with this data. So I have this school class I haven't done much with. I'm actually going to create a class method on the school. Let's see. All right, so we want to store this in. All right, so we want to return this data. So let's go back to my student class, and let's store this data in something called students. That can be an empty list, and then I'm going to have students here and append to that. All right, so basically I'm just going to be appending that dictionary of data. So it's called the student info to be more clear. And that's going to be, so actually I want to create student objects now. So let's actually create those objects. So I'm going to pass in here. And so this is where quarbs come back into play. So since I have a dictionary here, I could simply do my double asterisks, and that'll create a student object for me. And that's going to push it into my list. So I'm going to have a list of student objects here from my student info I'm going to create a student object and append that into my list here. All right, and then I'm going to return my students list here. So basically, my class method here should load all students, open up a file, read the data from it, create student objects, and return a list of students. So this method's doing quite a lot, but you know, that's kind of what we want to do with load all students. All right, hopefully you guys are following along. All right, so let me go to my school class because we haven't done much with it. So as we see here, we have a list of students and staff that we eventually want, but we actually have an empty list here. So now that I actually have some functionality for actually creating and loading student data, I can actually take advantage of that. And again, since this is a class method, I don't need an instance to do this work. So if I go to my school file, I can do something like student and load all students. So I was doing this in my runner file. I'm actually gonna get rid of that. And now I have my school be the authority for my students. It's gonna be housing all my students. So I'm gonna do something like that. I'm gonna need to import student because school is using it now. All right, so import my student class, and I think that should do what I want. Obviously, we should test it. The init method for school is going to load all students, call load all students on my student class, which is the class method, and then store all those students that it's going to be returned into my students list for my school. So hopefully the design here kind of makes sense. My school is maintaining all my students, so that's why I did it there. And then let's see, let's go to my student class, which is right here. I'm going to add a new instance method. Again, hopefully you guys are familiar with the str method. This is just a good way to print out data. So it's going to take itself. I'm going to return a string, and let's just create a quick string. In this case, I just want to print out self.name. All right, I'm not going to print out other information, but I totally could. But in this case, I just want to return the name of the student.
I have a quick question about that.
Yep.
Well, not exactly that, but do you not need to also import person in there because some of your student attributes are in person?
Are you talking about in my school file?
Yes, where you imported student.
Great question. So yeah, so Taylor's question was, do we need to import person here because person is actually storing some of our data here? The answer to that would be no, actually, but it might not be clear why, so we definitely should talk about it. So in this case, I'm importing student into my school file. So school knows that student exists, but school doesn't know anything about person. The reason that that's okay is because if we go to our student file, we're actually importing person here. So it's kind of automatically imported, I guess, what's the name? Transitive property is what I'm looking for. So in this case, school imports student, and then student imports person. Therefore, I think through the transitive property, if I remember my terms correctly, school kind of has access to person. It doesn't, sorry, I should rephrase that. School cannot use person. So if I wanted to do something like person, call person here and do something with it, school would actually complain because it doesn't know that person is a class. I would need to actually import person here. The reason I can import person from my student file is because my student file has imported person, so I can kind of pass that along if I wanted to. But since I'm not actually using person directly in my school file, I don't actually need to import that person because there's nothing person related going on here. I'm using students, and then students, the student class is using the person class here. So in this case, student needs access to person, but my school class does not need it because I'm not doing anything person specific here. It's indirectly.
Awesome, thank you.
It's indirectly being done through student, but that was a good question for sure. So again, if you did want to use the person class here, you would absolutely need to import it as such, but you don't need to have a separate import line like classes.person because the student file already has that person imported, so you kind of just pass that along. Yeah.
So that would cause an error if I did have from classes.person import person?
Nope, that would not be an error. That's just another way to do it. It's not going to collide. So like, yeah, you might think like, oh, that might be a duplicate import and issues might happen, but no, Python takes care of that. So I can do this also, just a little bit more writing. But in this case, if I wanted to import person, this is totally valid also. It's the same person object that's being passed either from the person file or through the student file, which is importing that from the person file. Great questions there, yeah. So importing definitely can get sort of tricky, but hopefully not too complicated. All right, so again, if this is working correctly, my students on my school class should have a list of students, and then I'm going to print that out. So I'm going to go back to my runner file and call, what do I want to do? School, print school dot students. All right, so as always, I want to run this and hopefully I have no errors. All right, so I got some output. Again, I got some ugly object, I guess, notation here. So then I added this str method on my student, but that's actually not being used. So if I scroll down, that's still not quite being used. So if I actually wanted to print this out, I need to add a str method on my school instance. So if we do that, just to make this a little nicer. All right, so if I want to print stuff out, I'll do a for loop. I'll do students, and self.students, and then print out each student. All right, so now that I have a str method in my school class, this will go through my students list and then print out the student object. And since I have a str method in my student class, I'll actually get the name of the student, since that's what I specified in my str class here. I'm printing out self.name. All right, so let's give this a rerun. And still no good. What am I doing wrong? Sorry, guys. So I'm printing out students. Oh, okay, sorry. So I just want to print out school here, because I'm calling the school method, so I want this str to be triggered. So I want to print out the whole school, not school.students. So let's clear that. All right, cool. And I got an error, so that's okay. All right, but I printed my students, Lisa, Jesse, Slater, Kim, Dave, Doug. So that looks good. I'm not sure where this error is coming from. We're line 7. Oh, sorry. I'm doing some silly stuff here. So I need to return a string from my string method. I'm not going to go through the motions here. I think I'm wasting too much time on this, but you guys can mess around with the str method if you guys want. But again, I should be returning a string from that method, not just printing something out. So that was my error there. My apologies there. All right, cool. So we kind of have our students being loaded, which looks great. Let's go back to my README, make sure we've handled everything. All right, so we did students, but now we need to do staff. So staff should be pretty similar. In this case, we have a staff file. So let's look at our staff file. Looks pretty similar to what we had before. Just some names here. I don't know why XX is a name here. Let's give that real name. All right, and then we have some roles, principal, janitor, teacher, teacher, principal. But otherwise, the data looks pretty much the same. We have a name, age, role, employee ID instead of school ID, and then password. All right, that looks pretty similar. So again, this is where we go back to shared functionality. So if I look at my student information, let me trash my terminal. So all the stuff I'm doing here is going to be pretty similar to what I'm going to be doing with my staff. There's going to be a few differences. For example, the file name is going to be different. Instead of students.csv, I want to do staff.csv. But otherwise, all this stuff, aside from a few variable naming, should be identical. So again, I could just copy this over to my staff class and copy, paste, and update some data. But that's, again, redundant code. And usually that's bad practice. So since I already have a base class of person, I actually can leverage that and kind of move the logic that I just created. And copy that, move it into my person class. Again, this is my base class for my staff and student class. So I can kind of share that functionality here. So it's still a class method. I'm going to rename this to load all people. And then this is actually going to take in a parameter of file name. So get rid of this. And use that. It's going to be people. Again, I'm just kind of updating this so it's generic to my person class. So I don't want to reference students because students doesn't really exist in this scope. All right, I think I've made this generic enough. I'm going to need my imports again, so I'm going to copy that from here. Got OS and CSV. So I'm going to remove that from my student class. So I import CSV, import OS, because I'm using that in this file. And again, this should be generic now. Load all people, open up a file path, create a people list, read the data, and store that into my, all right, so person info. All right, so one thing here, I have a student class I'm creating, but I actually want that to be generic. So that's where we can leverage actually the CLS parameter we're passing in. So I could just use CLS here because that's a class actually. All right, so that might be kind of weird, but this is just a reference to a class, to a full class, not an instance of it. So if I do this, I think this should work. So if I want to leverage that, I'm going to delete all this stuff. And then, sorry, I'll keep the top part. And I'll do something like return, let's see, super. Again, super is just calling our base class. And I think this should work. All right, so I'm going to do load all people. And then I'm going to pass in my file name. All right, so again, what this is doing, I'm specifying the file name, but otherwise just relying on my base class to do all the logic for it. So I think this should work, but again, always need to test. Let's make sure I didn't break any functionality. So if I go back to my runner file, bring up my terminal, which doesn't want to come up. All right, clear that. And let's run Python runner one more time. All right, we get Ridgemont High, nothing fancy there. Out here, and school.students, print student. All right, so that should work like I was trying to do before. All right, cool. So as you can see, I print out my high school name or my school name and then the students. So my students have not been affected. Again, always good to test when you kind of remodify or refactor your code, make sure you didn't break existing functionality. So in this case, I think I'm still good because my students are still being loaded. So again, just to review that in case I went over that too quickly, I have my person base class here. I moved my class method into my base class because I'm pretty sure I'm going to use that again for my staff class. And this is all just generic stuff. So basically I'm opening some file, and that file is a file name that I pass in. So that's going to be unique to, I guess, the object or the type that the data I want to read it. So in this case, I pass in students.csv from my student class. So that's the file name that's going to be passed in and opened. I open that file up, read the data, store the person info, and then return the people object that's created. So in this case, again, CLS, when I call this from my student class, CLS is actually going to be student, the student class. All right, but in this case, I don't want a hard code student in there, so I'm going to write CLS because this is the base class of person. All right, and then I return all the data loaded in my people list. Okay, so now that I
question.
Absolutely.
I'm not understanding the logic behind why you put the load all people in the person's class versus the school class, because from a design perspective, it makes more sense you would have that in the school class because you're dealing with logic that loads people into attending that particular school, not why are you loading the students and the staff in the person's class?
Got it. Yeah, great question there. Let's actually talk about that. So this again goes back to you guys being the software developers. You guys can kind of design how your code is structured. So there's many ways to structure code, and I'm not going to say one way is always better than the other. It comes down to your decision making. So we can't always say, hey, this is the way to do it. You have to do it this way. You guys are architects also, so you guys got to make those design decisions. And so yeah, Brian, I'm glad you're critically thinking and saying like, hey, why not just put the class methods here, right, in the school method? Like I'm calling student.load all students. Why not just have a class method here that loads all students, something like this, and define it here. So I'm not actually gonna go through that, but yeah, so I can just have this method and do the same logic that I'm doing and just do it here. That would work also. So I'll leave it up to you. So if you want to do it that way, totally fine with that. I think Brian's argument is that my school class is actually housing all these students, so maybe that should be the authority for loading all of them also. And I could see the argument. I just went a slightly different way. Again, I'm not saying one way is more right than the other. The reason I chose to do it this way is because since I have a student class, I feel like kind of loading and creating those student objects should still be in the student class. as a generic class method. Again, you can kind of rationalize it either way. So I'm not, again, Brian's suggestion totally works and makes sense to me also. So that's, again, either way, it's your preference, I guess, in that case.
Okay, thanks. I understand your logic now. Thank you.
Gotcha. But yeah, again, I'm glad you're thinking that way. And yeah, don't always, I'll say this as a generic statement. From our READMEs, sometimes we might suggest something and it may not be what you think is like the best way to do it. Feel free to kind of ad lib and go like, okay, I think actually, this class should be structured a little differently. Like we don't always want you just to follow directions blindly. Hopefully what we have written up is like a good guide and probably best practices. But I will say there's actually, one challenge in mind that I have later on in the curriculum where the directions are kind of like, add these features, but the features I feel like should actually be done a little different way. So I actually just did it what I think is more sensible. And this is where we're creating like a website and we have like a search feature and I don't want to get too into it, but yeah, again, definitely do some critical thinking and, make changes as you see fit. Obviously, we still want you to do all the requirements, but if there's something slightly different that you think is better, definitely, jump at that challenge and kind of do what you think is best. But yeah, in this case, I just have my class method in my student class because I'm loading students. So I feel like that should be specific to my student class. And all right, so I have this generic method.
Sorry, I wanted to add something.
Go for it.
So actually, you want your methods not even in school, but in another shared class. Otherwise, you're going to start rewriting methods between staff and students. And so, yeah.
I'm going to like rewrite these methods.
Yeah. So when you're doing load all students, usually you only want to access this like a file once because you don't want to keep accessing the same file. So you want to keep a data structure of what that file holds until you want to manipulate it or whatever. And then, so that you're not constantly accessing it.
So you're suggesting I should have like a intermediate class between person and students and staff?
Yep, where it will run the methods depending on if it's a student or a class, and also if you want to scale it up, what happens if you want to have more than one school? So
you're saying put the load all students method in the person's class and change it to load all people, and then you pass in a parameter whether or not it's a staff or student or janitor or whatever. So it's less hard coding, and then you're not repeating that particular load all method in the student and the staff files.
Exactly.
So I think we're sort of doing something like that. So we have this people class and then this generic method load all people. So I guess the only, duplicate is we're going to be passing in a file name. And I have a load all staff and a load all students method in my student and staff class. So I guess that is sort of redundant, as in I could just pass in my file name and call the people loader directly. So for example, if I wanted to make that step, I could do something like this, go to my school, and I could do something like, how would I do this? I think I could do something like person, if I had access to the person class, load all people, and then pass in a file name, but then I won't be able to create student objects. So I guess your suggestion definitely might work. I'm a little hazy on the implementation details, but I'm just going to proceed with this because I like the design that I have. But again, I like that you guys are thinking about other altered designs. Again, there may be better designs. Again, don't rely on me for necessarily best practice all the time, but I think the design I have here should be generally good. Again, we have a shared base class being person. We have a generic method. In this case, staff is just going to pass in the file name, and then we're going to load all the staff and return it. And likewise, students going to pass in a file name, and we're going to load all students. So again, the key here is this person class can use the CLS parameter as a class. So I'm actually creating an object here using the CLS that's passed in. And that CLS will be student for when the student class calls this method. And then it'll be staff for when the staff class calls this method. So either way, my people list is going to contain the correct objects, whether they be students or staff. So in this case, I'm going to close my data files. Staff, again, loading staff.csv. Otherwise, I call load all people on my base class. Again, I'm using that super method that we talked about earlier and passing in a file name. So if I did this correctly, Cross my fingers. Let me load my staff because school needs access to the staff class. Staff, and in this case, I want this to be student. And I'm going to copy that. Okay, so I think I maybe understand Ahmed's suggestion maybe a little better. Instead of doing this, I could do something like student.loadAllPeople. I think this should work, and then pass in a file name here. So that would kind of, if I did this, sorry, I don't want to jump through too many changes, but just to kind of go through my thought process, I could do something like this. All right, so I have two versions here. I have staff that calls loadAllStaff, not students. All right, so in this case, I actually have a method on my staff class, a class method that's called loadAllStaff, and this basically just takes a file name and passes it to my base class, which is person. Or I could do something like this, where I have my student class, I call loadAllPeople, which is inherited from the person class. So again, my student, I can get rid of this temporarily. All right, so my student class has nothing to do with loading anything, but we're inheriting from the person class. So again, we're going to go over to inheritance today. So again, if these concepts aren't familiar, they should be familiar by the end of today. But this person class is basically giving access to this loadAllPeople method. So if I hypothetically wanted to call loadAllPeople on my student class, I could definitely do that and pass in a file name. So I think this should work also. I think I might need to pass in. Let's see if this works. I'm actually curious. So let's get this run. If there's an error, I'll deal with that later. So since I have staff populated, let me print out staff. Hopefully you guys are following along, but again, stop me if I'm going a little too quick. I'm going to go to my student, strip off this str method, move that down to my person class. So I have a str dunder method there. And all right, so my goal here is to print out all my students and all my staff, assuming that I load them correctly from my student and staff files. All right, so let's bring in my terminal. I'm not sure if this will work based on what I added to my school class, but all right, that actually worked. So in this case, my students are Lisa, Jesse, Slater, Kim, Dave, and Doug. And then my staff are Culpepper, Dewey, Mertz, Dickerson, Heimlich, and Belding. All right, so just to kind of go over the two different ways we did it. In one method, I created an intermediate, function or method that's called loadAllStaff, and that's going to take care of passing the correct file name. Versus here, I don't have an intermediate method. Instead, I'm calling loadAllPeople directly, and I'm passing in the data file. So I actually prefer this method just because I want my staff class to kind of house all of its pertinent data. Like I don't want my school method to kind of be responsible for the data, like name of the data file. I rather kind of just have that nested so the student class manages all that. Again, not necessarily wrong. It's just kind of how you want to go about designing your applications. In this case, I'm going to actually call loadAllStudents, which I commented out here. Let me uncomment that. All right, so my class method loadAllStudents will loadAllStudents. My loadAllStaff will loadAllStaff via this loadAllPeople shared method in my base class. All right, so I think that should take care of all the stuff we need to do. We're loading staff, loading students into our school. It's sort of similar to what we did here. And then stuff up. All right, so I think that takes care of school interface 1. Again, this isn't a full application, but there's gonna be several iterations on this. So eventually we're gonna get to a more capable, more feature-rich application. So I'm gonna actually do a git add, git commit with the message, completed, loading, student, and staff data. I have a long message there. All right, cool. And then I'm gonna actually git push now. So git push origin. That's what I wanna do. All right, that looks like it works. And that's school interface 1. I'm gonna stop recording.